Our topic is determination of order of reaction. As there are 6 methods to find the order of reaction: method of hit and trial, graphical method, differential method, half-life method, the method of log excess, and initial rate method. We will discuss the method to find the order of reaction by half-life. As it's mentioned earlier, the half-life of reaction is always inversely proportional to the initial concentration of reactants raised to power 1 less than the order of reaction. Therefore, this can be given in the following expression, which is the half-life to the base n directly proportional to 1 over A into n minus 1. Let us perform a reaction twice by taking two different initial concentrations A1 and A2, so their half-life periods are found to be T1 and T2 respectively. So following will be their expressions. So we will divide these both two expressions and we will get T1 over T2 equal to A2 over A1, and both will have the powers of n minus 1. So due to this, the power will become to the whole power. So this equation will become T1 by T2 equal to A2 over A1 to the whole power n minus 1. So now we take the log on both sides, as the log T1 by T2 equal to n minus 1 into log into A2 over A1, as according to the rules of mathematics, the power comes at first when the log is added. So on rearranging the above equations, we will get n is equal to 1 plus log T1 by T2 over log A2 by A1. So if we know the two initial concentrations and two half-life values, we can calculate the order of reaction. As there's another method to discuss, which is initial rate method, the effect of change in concentration on the rate of chemical reaction can be understood from the following gaseous reaction. As this means that this method helps us to find the effect of change in concentration on the rate of chemical reaction, and by this we can find the order of reaction. As we have an equation which is 2NO, mean 2 nitric oxide plus 2 moles of hydrogen, gives us 2 moles of water plus nitrogen. So we'll plot the data in a table which gives us this. The table is given to us to find the order with respect to NO and with respect to H2 and to find the rate difference. So first of all, we will find the order with respect to NO. To find that, we will consider that intensities in which the hydrogen concentration is constant while the NO doesn't have. So these intensities are 4th and 5th one. So the formula for this is rate 5 divided by rate 4 equal to concentration of NO5 over concentration of NO4 raised to power m, as m is the order for this reaction. So when we put the values in it according to the table, we will get the answer m is equal to 2, which is the rate according to the NO. So now we will find the order with respect to hydrogen. So at this moment, we will take those intensities on which the NO has constant concentration, and this is 1 and 2. So here we will write the formula rate 2 over rate 1 equal to concentration of hydrogen at 2 and concentration of hydrogen at 1 raised to power n. N is its order. So after putting the values from the table into this equation, we will get the order with respect to hydrogen, which is n is equal to 1. So as the rate is directly proportional to the both concentrations, and we have get the order with respect to the both reactants concentrations, here we will make a rate equation which will be equal to K into H2 into NO raised to power 2. So here we will make a sum of 1 plus 2 equal to 3. As the 1 and 2 comes from the orders which we find specifically for NO and specifically from hydrogen. So that's why the order of this reaction is 3.